everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. I'm going to talk about the project that we have in the end of this presentation, but the topic of the presentation today is the evolution of trust, from trust in God to trust in AI. Trust is our probably most valuable asset, and right now it's being taken apart like a cheap flat screen from a Black Friday sale. In the past, the world was simple. People believed the evening news, or the professor with the dusty books, or the doctor with a clipboard and furrowed brows. But what is happening today? A TikTok AI avatar with a convincingly serious voice explains the financial markets, while chatbots provide medical diagnosis more reliably than some family doctors. Trust is a key, but where is the keychain? So what is the problem? Information and disinformation move at the same speed. What does that mean for our trust? Who decides what is true? And most importantly, can we trust a machine that has neither morality nor real judgment, but only simulates them? Sure, trust evolves. The only question is in which direction. Two recent studies, one published by in the journal Science, and a working paper, but a researcher called Goel, provide initial scientific evidence that AI-based interventions can help steer people away from false beliefs. Like in the first study, the study finds with the study which had 2,100 participants. Personalized conversations with ChatGPT led to average reduction in conspiracy beliefs by 20%. The effect lasted for over 2 months, indicating a lasting change in opinions. Particularly noteworthy, even among individuals with strong conspiracy beliefs, like being true believers, a significant reduction was observed. Impressive and terrifying. If an AI chatbot can reduce conspiracy beliefs, it can just as easily amplify them. The effect lasts for 2 months. Is the world of opinion shaping? In the world of opinion, that's an eternity. The real question, who controls the narrative? Because if algorithms can shape beliefs, then it's no longer people in the driver's seat, but machines, or those who program these machines. In the second study, in an experiment with 1,600 participants in the US, researchers examined whether people trust AI-generated information more than human sources. The results showed that GPT-4 was similarly effective in correcting false beliefs as a presumed human from the sample, but less convincing than a recognized expert in psychology. The studies suggest that AI can serve as a tool for enlightenment, but with limitations. Our trust in a source depends not only on factual accuracy, but also on perceived credibility. Similarly put, AI can deliver facts, but it cannot force trust. People believe people, especially those with authority. GPT-4 is convincing, but it lacks the charisma of an expert. So the real question is what happens when machines learn to be not just accurate, but charismatic. People trust faces, not lines of code. The fact that AI-driven conversations can keep up with human discussions is impressive, but there's a limit. Studies show that we are more likely to believe someone with doctorate and graying temples than an anonymous source, even both say the same thing. And why is this? Because our brains are conditioned to respect authority. The second study confirms exactly this. An expert persuades while AI just informs. The difference into both of these things is trust. And trust is not just a matter of logic, but of psychology. Here lies the paradox. AI can provide objective, fact-based answers, yet people prefer to trust other people. Why? Because trust is not purely a rational process, it is emotional, social, and culturally embedded. Even if AI can demonstrably reduce beliefs in conspiracy, its influence may always be limited. Trust is not built on accuracy, but on connection. We want to see eyes, hear a voice, feel a story. The real challenge then is not just whether AI tells the truth, but whether we are willing to listen. While these findings suggest that AI can spread knowledge and reduce misconceptions, it also carries risks. In the studies we mentioned, they highlight the success of AI interventions heavily depends on how people perceive AI. If AI is seen as a manipulative actor, it could actually reinforce distrust. Moreover, it remains unclear how repeated exposure to AI interventions may impact trust in human expertise in the long run. Trust is fragile. Once it is shaken, it's hard to repair. And this is precisely where the risk of AI use lies. Yes, it can spread knowledge, combat misinformation, and shape beliefs. But what happens when people see it not as a helper, but as a manipulator? According to the studies we mentioned, the success of AI interventions depends on how they are perceived, and perception is reality. If people feel that a machine is trying to re-educate them, distrust is inevitable. What does this mean for long-term trust in human expertise? If AI consistently corrects us, we are eventually believe, will we believe eventually less in professors, journalists, or doctors because the algorithm supposedly knows better? The irony is the technology could strengthen our trust, um, but could just as easily undermine it. Whether AI is seen as an enlightenment or a manipulator is not decided by the machine, but by us. Another problem is that AI can be used not only for enlightenment, but also for disinformation. Deepfakes, automated fake news generators, and algorithmic biases demonstrate that the same technology used for education can also be explored for manipulation. If a system requires perfect human behavior to function correctly, then it is bound to fail. In this sense, firmly believing that AI can be used solely for good would not only be naive, but it would be hyper exponentially optimistic. The studies we mentioned make one thing clear. AI can combat misinformation, but it won't reprogram human psychology. Trust isn't built on facts alone, it is shaped by social dynamics. We trust people, not just data points. As expert with charisma will outperform our algorithm with perfection ever. So what is the real challenge? Integrating AI in a way that is seen as an ally, not as Orwellian thought police. Because if people feel that machines are taking control, the biggest casualty won't be misinformation but trust itself. If AI changes our perception of truth, it won't be through mere information delivery, but through the way we socially contextualize it. The real question is not just whether we trust machines more than humans, but how we redefine the mechanism of trust in a technology-driven society. Trust is not a static concept, but a living, evolving fabric of expectations, experiences, and social constructs. In a technology-driven world, the question is not just whether we trust machines more than humans, but rather how do we, the very nature of trust, transform when algorithms make decisions for us, when transparency is replaced by complexity, and when mistakes are no longer human but systemic and machine driven. Humans have always trusted out of necessity. First, our senses, then tools, and later institutions. Now we face the next stage of evolution, trusting something that does not measure itself by our standards, but develops its own logic and mechanism. Trust in a machine is not an act of blind truth, but a calculation of reliability, transparency, and ethical programming. But can trust endure when it is no longer tied to responsibility? The paradox is the more flawless the machine, the more unforgivable is the mistake. A human doctor is allowed to make mistakes, but AI is not, even though both operate within probability. The truth remains a system that depends and demands perfect behavior is destined to fail. That is why the real question is not just how we trust machines, but how we redefine our tolerance for errors and unpredictability. The challenge lies not only in technology, but above all in our ability to shape trust in the end of opacity. The question remains, in bots we trust or not? And with this, we are ending this educational presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder of the Decentralized Web project. I'd like to tell you about this project and several other projects that we're working on. First, the Decentralized Web project is building a decentralized communication and advertising platform. It is monetized through advertising, and this advertising is very permissive. Like people, they request showing advertising, and they go through page by page of advertising by clicking to load the next advertising on the screen. In the Decentralized Web project, we have our own blockchain instance, and this blockchain instance gives the rewards for the users, namely rewards for becoming a new user to the platform. There's also reward for inviting other users, other people to become new users on our platform, and of course rewards for viewing advertisement on our platform. Our decentralized communication and advertising platform is not based on blockchain type of decentralization, but the essence of decentralization as we're seeing it is a direct communication from user to user without going to a third party, namely a web server or a point to store information which is related from one party to another party. The communication is done directly from user to user without going through other points of exchange of information or storing of information. And with this said, I like to tell you the name and the URL of the website of this project. It is decentralizedweb.org. Decentralized and web, these are two words and they're typed all together. Decentralized web. Then there's dot and it ends with org. With this said, I'm going to the second project that we are working on. This project is a marketplace and a collection or multiple collections of non-fungible tokens. And what is interesting, unique, and special about these non-fungible tokens is that they are based on three-dimensional objects. With three-dimensional objects, the challenge is to load, read the file of the 3D object, then display this 3D object, and then manipulate it in a desirable way. Usually, creators of 3D objects they use game engines, and currently there are two very popular choices of game engine used for displaying of 3D object. One of them is one of these game engines is Unity, and the other one is Unreal. But from the very beginning of our project, we decided to build our own 3D software engine. And what this 3D software engine does is it reads the file of the 3D object, it opens a window in a computer screen, it loads and displays the 3D object, and then it starts animating the 3D object in a way of moving the 3D object in a random fashion around the window it did open. But in addition to this initial and basic capability for our 3D software engine, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D software engine is the capability of speaking. The 3D NFTs can speak in one of three basic voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed manner, or in a fast speed manner, or in a slow speed manner. Like for example, if we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a very masculine person or the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. The next additional and important capability brought by our 3D software engine and offered and assigned to our 3D NFTs is the capability of voice recognition. If, for example, we have 3D NFT which is moving in a random fashion, being animated, then we can issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The next additional but not least important capability for our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, And then the 3D NFT is going to tell you in few sentences who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or decentralization or the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability to display them in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in a blue or bluish colors. Then you can come to our website of the 3D NFT marketplace, and now is the time to tell you the name and the URL of this website. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and all of the other pages of the 3D NFT marketplace, you can see several links. One of these links point to links to accessories. When you click on this link, you're going to see that we are offering special glasses. You can order one pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue cyan. Then you can request displaying the 3D NFT in a way of stereoscopics. You can put the special glasses on, and then you are going to see the 3D NFT is coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D software engine and the 3D NFTs, but I'd like to mention a few things about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. It runs Ethereum software, and it is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain. It runs Polygon Matic chain. It runs Avalanche Avac chain, and it runs multiple other famous or not so famous blockchains. By having our own blockchain instance, then we do not charge our users gas fees for the deployments of the smart contracts for the non-fungible tokens, and we do not charge gas fees for the transactions of transfer of ownership from one user to another user. In this way, we detach our 3D NFTs from a single crypto coin, and currently we offer purchasing and then receiving proceedings from sale of our 3D NFTs in multiple crypto coins. Currently, the choice of crypto coins include 4 different coins. It includes Solana Sol, Polygon Matic, Avalanche AVAX, and KuCoin, which is a big centralized crypto exchange. They have a coin called KCS. But in addition to buying in crypto and receiving proceedings from selling crypto, we have a second parallel and independent way of buying and selling of 3D NFTs done entirely in fiat currency. Like I can give an example, like if you're a user and you come to our 3D NFT marketplace, you click on the composite image of our first collection of 3D NFTs, and then you are going to see all of the 3D NFTs listed one after another. You can now browse through the collection of the 3D NFTs. Then you see a 3D NFT that you like. You click on this 3D NFT, and then you are going to see a video of this 3D NFT as it is moving, and you're going to see a drop-down menu which is giving you a choice of purchasing with 4 crypto coins, and a fifth choice of buying with fiat currency. So let's say you select buying with fiat currency, and then you're going to present it with a screen which is asking you to put the number of your debit or credit card expiration date and CVC. When you click on the button to complete the transaction and make the payment, what is going to happen is it is going to be a transaction and conversion from your national fiat currency, which could be different than US dollars, and this payment is going to be converted from your national fiat currency to US dollars and deposited in our bank account. So what is going to happen then is there is going to be a transaction and transfer of ownership, the initial ownership from our 3D NFT marketplace to you, and now you become the first owner of this 3D NFT. You can play for a while, and then at some point you may decide to put this 3D NFT for sale. You decide on the price that you want to put for sale, and let's say there is a second user who comes to our 3D NFT marketplace. They browse through the collection of the 3D NFTs, and they see and like in particular the 3D NFT that you put for sale. They're going to go through the same choices of choosing between 4 crypto coins and fifth choice of paying with fiat currency. And let's say they select payment with fiat currency. Then what is going to happen is they are going to be putting the number of their debit or credit card expiration date, CVC, and when they click on the button to complete the transaction and make the payment, what is going to happen is there's going to be a conversion from the national fiat currency of the second user, which could be different than your national fiat currency, and it is going to be converted to US dollars and deposited in our bank account. So what is going to happen next is there's going to be a transaction and transfer of ownership from you to the second user, and now the second user becomes owner of this 3D NFT. Then there is going to be a third action, and there's going to be a transfer and conversion from US dollars to your national fiat currency, and this transfer is going to be deposited in your bank account in your national fiat currency. And with this said, I'm ending talking a bit about this second project. I'd like to mention a third project that we're working on, and this project is about building products for charging of electric vehicles. Currently, the number of electric vehicles on the market is growing, but at some point the number of these vehicles may start exponentially growing up, and the way these electric vehicles are charged may ultimately become insufficient to handle this exponential growth in numbers of electric vehicles. Currently, electric vehicles are being charged in a way I can compare to the way internal combustion engines are being fueled. Internal combustion engines are coming to places called gas stations, and owners of these internal combustion engines connect fuel hose from a gas pump to the gas tank of their vehicle. They start loading fuel. They pay for the fuel. They disconnect the fuel hose, and they leave the gas station. In a similar way, owners of electric vehicles, they are coming to charging stations which are outfitted with few charging stations, and the owner of electric vehicle is connecting a cable to their electric vehicle. They start loading energy to their electric vehicle. They stay for a while at this charging station while their electric vehicle is being charged with electric energy, and then they pay for the electric energy which was loaded in their electric vehicle, and then they leave. But with the growing number of these electric vehicles in the market, we estimate that the number of these charging stations is going to ultimately to become insufficient to charge this growing number, exponentially growing number of electric vehicles. So what we're proposing is so-called parking lot model, where parking lots could be outfitted with products like the ones we're building, and these charging stations could help owners of electric vehicles which are living in high-rise residential buildings which are outfitted with ground floor parking lot or multiple underground floors of parking lots. In these parking lots outfitted with charging products like ones that we're building, the owner of the electric vehicle can come like in the evening after work, and they can connect charging cable to their electric vehicle, and they can leave their electric vehicle to charge during the evening, during the night, and during the early morning while they're at home in their residential apartment building. But in the same way, a number of owners of electric vehicles, they're working in high-rise office buildings, and these high-rise office buildings, they're outfitted with ground floor parking lot or multiple underground floors of parking lot. In the same way, when the owner of electric vehicle comes in the morning to work in this high-rise office building, they can connect electric cable to their electric vehicle, and they can leave their electric vehicle to charge during the morning, afternoon, and early evening while they're at work. With this said, I like to tell you a little bit about the type of product that we're building. The type of product that we're building is going to be outfitted with 2 or 4 electric vehicle cables, which could handle charging of 2 or 4 electric vehicles. And our electric vehicle charger is going to be outfitted with high current and high voltage electric switch. It is going to be outfitted with a near-field communication reader, which could read the debit or credit card of the user, and the user could identify themselves to the charger with their debit or credit card. Also, they could, the owner of this electric vehicle, they could be given a near-field communication card, which is the size of a credit card, or they could be given a near-field communication token, which they could place in their keychain, or they could be given near-field communication ring, which they could put on their finger, and they could identify themselves to the electric vehicle charger. But in addition to this, they could, owners of this electric charger that we are building is outfitted also with Wi-Fi connection, and this Wi-Fi connection could be connected to other chargers in the same parking lot, and it could be also connected globally to provide information to either to us to collect this information, or they could provide information to the strata of the residential building, or the owner of this high-rise office building, or to the electric utility, or the electric transmission companies. This is very, very important to provide this information to, for example, high-rise office buildings, because high-rise office buildings has an envelope of energy. They are committed to consume during the, for example, calendar month, and if they exceed this electric energy, they could be charged much higher fees for the excess energy, in the energy in excess from what they committed to consuming. In the same way, this is very, very important capability to provide to the electric utility or the transmission companies, because the electric utility has to balance at every moment the amount of generating energy with the amount of consumed energy. If the amount of consumed energy rises suddenly and exponentially up, then electric utility cannot provide sufficient generating capability. It needs time to bring additional generation capabilities, And in this time, while it struggles to provide additional generation capabilities, it has to turn off the electric energy so that it reaches again a balance in energy generated with energy uh, consumed and provided. And this could lead to blackouts to neighborhoods, cities, or regions, while the electric utility is bringing additional generation capabilities. With this said, I like to tell you the name and the URL of the website of this project. It is power.arstec.com. Power is the ordinary word for power. Then there is dot, then there is a word which I can spell it letter by letter. It's Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel. Altogether, it is Arstec. Then there is dot and it ends with com. Once again, power.arstec.com. In our website, we did provide a link to an article which compares gas station model with the parking lot model, and it provides much bigger detail than what I did describe here. But in addition to this, we did provide 3 different surveys which you, the user, could fill and give us information about your wishes. The first survey is about hardware, the second survey is about software, and the third one is about features of electric charging products. And with this said, I'm ending talking about this project, and I like to mention the fourth project that I'm working on. The fourth project is about building AI agents and aiming these AI agents in a new category, namely entertainment or just for fun category. So what we're building is very different than most of the AI offers, and the difference is that most of AI offers are between human and AI. The human requests something, and then AI is responding to an answer or certain actions which it is doing. But in our AI offering, what we are having is the human is defining an interaction which is going to happen between two different AI entities, and these AI entities are based on different large language models, and they also have their own gender, their own avatar, and their own pitch of voice with which they're actually speaking. After the user defines the interaction, then the user just starts this interaction, and then the user just enjoys the interaction between one AI entity with another AI entity. And it is going back and forth between two AI entities when the request of one AI entity is going to the second entity replies, which becomes a request to the first AI entity. And when the user ends this interaction, the user stops this interaction, the script of this interaction is saved for the user, and the user could also share the parameters of this interaction with other users, post it on our website so other users could see the parameters of this interaction, and they can try it for themselves. But what kind of interactions we are offering? The initial interaction that we did a test with is an interaction where we define the first AI entity as female, having a high voice pitch, and the appropriate avatar for this AI entity. And we put the parameters for this AI entity as it being very seductive. And we have second AI entity, which is has a gender of male. It has a low voice pitch and the appropriate male avatar. And we put the initial prompt to this AI entity to be very angry. And then we are enjoying this fun interaction between female AI entity, which is trying to seduce the male AI entity, and the male AI entity respond with angry responses to the female AI entities, which then continue to try to seduce the male AI entity. But you, the user, can define many other interactions, like, for example, one AI entity trying to sell something to the second AI entity, namely selling a washing machine or selling a car to the second AI entity. And the second AI entity can resist this sales pressure and respond with their resistance. With this said, I would like to tell you the name and the URL of the website of this project. It is ai2ai.decentralizedweb.org. AI2AI is typed in a way of the letter A followed by the letter I, followed by the number 2, followed by two other letters, A and I. And it is typed all together, AI to AI. Then there is dot, then there are two words, decentralized and web, they're typed all together, decentralized web, then there is dot, and it ends with org. Once again, ai2a.decentralizedweb.org. We just released this project, and we will appreciate and we would be grateful if you go to the website of this project, you download the program, you start it, and you enjoy the interaction between two AIs. We provide credit for new users so that you can evaluate and enjoy this interaction freely. And then you can top up to add funds to this to enjoy additional interactions through our website. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.